All right, folks, we have now finished up everything that we needed to do with functions. And so we're ready today to move on to exponents. Now, just in the way of review, you all will remember that an exponent is a way to show repeated multiplication. So an exponent is a way to show repeated multiplication. So when we use an exponent, what we're saying is we want to take a number and multiply it a certain number of times. So you all are accustomed to seeing things like 2 raised to the 4th power. 2 raised to the 4th power. Now in that expression, the full size number, the big number, is called the base. Now, the base is the number that is going to be repeated over and over and over again in your multiplication problem. So that large size number, that full size number, is called the base, and that is the number that is going to get repeated in this multiplication problem that you're going to do. And of course, that smaller number is your exponent. And it is the exponent's job to tell you how many times to repeat the base in this multiplication problem. So when I see 2 to the 4th power, I am going to repeat the number 2 4 times in a multiplication problem. So what this exponent is telling me is it's telling me to take 4 2's, telling me to take 4 2's and to multiply those 4 2's together. So you all know that 2 to the 4th power means 2 times 2 times 2 times 2. We're going to do a repeated multiplication where 2 is going to be that repeated number, and the exponent tells me how many times he is going to be repeated. Now if I work this out, 2 times 2 would be 4. That would make it 4 times 2 times 2. And then 4 times 2 would be 8. And then 8 times 2 would be 16. So 2 to the 4th power would ultimately be 16. So exponents are repeated multiplications. You all also know in the context of algebra that instead of having a number for the base, we can often use a variable. So I could have x to the 3rd power, which is also read as x cubed. When I see x raised to the 3rd power, I'm going to repeat the base of x 3 times in a multiplication problem. So this is telling me to take 3 x's and multiply those 3 x's together. So the base is what you're going to repeat, and the exponent tells you how many times. If I had a to the 2nd power, which you also know as a squared, that means I'm going to take the base of a and repeat it twice in a multiplication problem. So 2 a's are going to get multiplied together, so a times a. So that's just a quick reminder about how exponents work. It's repeated multiplication, and the base, the larger number, is what's going to get repeated, and the exponent tells you how many times you're going to repeat that. Now, specifically what we're going to be working with for the next couple of days are some laws of exponents, or exponent rules, that tell us in algebra how to work with these exponents. You did these, I'm sure, in your Algebra 1 classes, but we're going to take the time definitely to review all of the laws of exponents here. There are a total of 5. We're going to look at 2 of them today, and then we'll catch the other 3 tomorrow. The first law of exponents that I want to talk about, that I want to review with you, is called the product rule. The product rule. And you all will remember from your previous math classes that the word product means the answer to a multiplication problem. So this product rule is going to tell me how to work with exponents when I am doing multiplication problems. So here is what the product rule says. It says if I have a base of x raised to the a power, and I multiply that by a base of x raised to the b power, that the answer for that will be a base of x to the a plus b power. So I want you to notice what this is saying. First of all, I want to point out that on this side, you have a multiplication problem. On this left-hand side, you have a multiplication problem. And in that multiplication problem, you're multiplying 2 things that have the same base. So I want you to notice right off the bat that the bases have to be the same. It can't be an x and a y, or a 2 and a 3. You've got to have exactly the same base. And I want you to notice over here that that base stays the same. So throughout this problem, the base is x. Here we have an exponent of a, here we have an exponent of b. What this product rule tells us is that if you're multiplying 2 powers that have the same base, that you can keep that base and then just add the 2 exponents together. So let's put this into an actual problem. Let's say that I wanted to do x to the 2nd power times x to the 3rd power. Okay, according to this product rule, that would be the same thing as x to the 2 plus 3 power. I would add those 2 exponents together, so the final answer for this should be x to the 5th. So simple as that. The product rule tells me that when I'm multiplying 2 powers and they have the same base, that I can just simply add those 2 exponents together. Keep the same base and add the 2 exponents together and make that simpler. Now let's talk about why this works. Let's talk about why this works for just a second, okay? So first of all, let's take this first part of this product rule. We have x to the 2nd power. Now what we've already said is that that is repeated multiplication. So this problem is telling me to repeat the base of x 2 times in a multiplication problem. So this part would be x times x. Now I've got my multiplication sign here in the middle. So right here is my x squared. Now it's times x to the 3rd. Now this, again, is repeated multiplication. That's saying to take a base of x and repeat it 3 times in a multiplication problem. So that would be x times x times x. So if I write x to the 2nd power times x to the 3rd power out the long way, write it out as repeated multiplication, then this becomes x times x times x times x times x. Now, when I look at this, when I look at what I have written here, what I see is repeated multiplication. I'm repeating x in this multiplication problems a total of how many times? Well, you can see it. It's 1, 2, 3, 4, 5 times. So that's how this becomes x to the 5th power. So that just kind of shows you why that works. Here you're repeating x 2 times in a multiplication problem. And then you're multiplying that by x repeated 3 times in a multiplication problem. So what you end up is with x just getting repeated a total of 5 times. So x to the 5th power. So the product rule tells you that when you need to multiply powers and they have the same base, that you can just add the exponents. So with that said, Let's do a few examples here. Okay, if I wanted to do a to the 4th power times a to the 5th power, according to the product rule, when I multiply two powers and the bases are the same, I can keep the base of a and add my exponents. So 4 plus 5 would make this a to the 9th. If I wanted to do b to the 5th power times b, now let's talk about this for just a minute. The base here is b, and it's repeated 5 times. The base here is b, and I want you to notice it appears that it doesn't have an exponent. But if I have just a b, then that b is being repeated just 1 time. So be aware that all variables in a problem have an exponent, even if you can't see that exponent. So if it's missing, that means there's an invisible 1 there. So this is really b to the 5th power times b to the 1st power. Now, since the bases are the same, I can just keep that base and add my 2 exponents, so that would be b to the 6th. Now, I think you can see those 2 examples, fairly simple here what we're doing. What I want you to also be aware of, though, is that we can do this with multiple variables. So I could do something like a to the 2nd, b to the 4th, times a to the 3rd, b to the 5th. So notice, this is a multiplication problem here. And what you'll do is you'll just multiply the bases that are the same. So to kind of rearrange this a little bit, if I want to do a to the 2nd, b to the 4th, times a to the 3rd, b to the 5th, then what I would actually want to do is multiply the a to the 2nd times the a to the 3rd, as well as the b to the 4th times the b to the 5th. So if it's a multiplication problem and there are multiple bases, just use that product rule for each base. So a to the 2nd times a to the 3rd, you would add those 2 exponents and get a to the 5th. And then b to the 4th times b to the 5th, you would just add those 2 exponents and get b to the 9th. So it truly does not matter how many variables they choose to put in these problems. You just use the product rule for each variable, for each different base. So if I were to do x, y to the 2nd, z to the 3rd, times x to the 4th, y, z to the 7th. This is a multiplication problem that I'm looking at here, so I can use the product rule. But what I'm going to have to do is use that product rule once for the x's, and then once for the y's, and then once for the z's. So I'm doing x to the 1st times x to the 4th, which would be x to the 5th when I add those exponents. I'm doing y to the 2nd times y to the 1st, which would be y to the 3rd when I add the exponents. And then I'm doing z to the 3rd times z to the 7th, which would be z to the 10th when I add those exponents. So the product rule applies to all multiplication problems. And what it says you should do is that you should add the exponents that are on the same base. So use that product rule, that adding the exponents for each base that's in the problem. Now let me add one more thing to this. Let's say I had something like negative 2x squared times 4x to the 3rd. Now you'll notice what I've introduced into this problem are these extra numbers, the negative 2 and the positive 4. Now here's what you need to know about those. Those numbers, that negative 2 and that positive 4, are called coefficients. Those numbers are called coefficients. And they do not get treated the same way as exponents, the same way as the exponents do. So you are not going to add negative 2 plus 4. Coefficients, you need to do what the problem says. So this is negative 2x squared times 4x cubed. So this is a multiplication problem that I'm attempting to do. So I should multiply these two coefficients together. So I'm going to do negative 2 times 4. When I do negative 2 times 4, I get negative 8. But then the product rule will take over with the exponent part of this, because I'm doing x to the second times x to the third. So I will keep that base of x and then add the two exponents together. So that's going to be x to the fifth. So notice when you're doing these problems, you have to treat your coefficients, those full-size numbers, differently than you treat the exponents. So with the coefficients, do what the problem says. It's a multiplication problem, so multiply them. But then the product rule says that when I'm doing a multiplication problem, I would add those exponents together. So with that said, let's do one last thing here. Let's do 12 a to the fourth b times 3 a to the fifth b to the third. So notice, multiplication problem that I'm doing here. So I'm going to start with these coefficients, and I'm going to do what the problem says. It's a multiplication problem. So I'm going to multiply my coefficients. 12 times 3 is 36. But then when I start dealing with these exponents, I use my product rule, which says that when you're doing multiplication problems, you should add exponents. So I'll have to do that for the a's, which will give me a to the ninth. And then I'll have to do that for the b's. Don't forget this b is to the first power, so it would be b to the fourth, 1 plus 3. So product rule tells you how to handle multiplication problems, and it says, so this is our product rule. It says that you should multiply coefficients, and then you should add exponents. And let me add here that are on the same base. So for each different base, add the exponents. All right, so that is your product rule. And you'll use that a lot. You'll use that a lot, not just in Algebra 2, but for those of you headed on to trig and to pre-calculus and calculus, any math that you take after this that's above Algebra 2, you will continue to use these exponent rules. So they're pretty important. And you know, I know you did them last year in Algebra 1, or not last year, but 2 years ago in Algebra 1, but I like to make sure we review them pretty thoroughly, just so I know that you're up to speed and remember all the details. All right, now the second exponent law that we're going to talk about is the power to a power rule. So the power to a power rule. Now here's what he looks like. You will have a base raised to a power inside parentheses. So it'll be wrapped up in parentheses. And then what you'll have is all of that being raised to another power that is outside the parentheses. So you have x being raised to the m power in the parentheses, and then all of that is being raised to the n power on the outside. So that's why this is called power to a power, because you're taking a power that's inside the parentheses and you're raising it to another power on the outside. Now, here's what this rule says. It says that if you have x being raised to the m power, and then all of that is being raised to the m power, that will be the same as x to the m times n power. So I want you to notice again here how the base doesn't change. So this is like the product rule in that sense. We don't change the base. But what this power to a power rule tells you to do is to multiply the two exponents in the problem together. And I think that makes a tremendous amount of sense, because notice how you've got this m and then parentheses and then the n. Parentheses mean multiply, so you can clearly see that m times n in that problem. Now, let me show you why it works. Okay, so let's say we're doing the problem x to the second power, and we want to raise that to the third power. this product rule tells us that to get this done, all we would have to do is multiply those two exponents together. So this would be x to the 2 times 3 power, which would give us x to the 6th power. Now, let's make sure that we see why this works, okay? So I want you to think about this. Exponents are repeated multiplication. So I want you to look at this exponent of 3 right here. We are going to repeat something 3 times in a multiplication problem. Well, what is that something that we're going to repeat 3 times in a multiplication problem? Well, it's x squared that's being raised to the 3rd power. So I need to repeat x squared 3 times in a multiplication problem. So I'm going to take 3x squareds and I'm going to multiply those together. Now, I'm going to go ahead and carry this multiplication dot down, and I'm going to go ahead and carry this multiplication dot down. And then when I look at this x squared, I know that's repeated multiplication. So I know that means repeat the x 2 times. So this x squared is going to become x times x. And then this x squared is the same thing. It's going to become x times x. And then this x squared, same thing. It's going to become x times x. So I want you to notice when I'm all done writing out all this stuff, that what I have is an x that's being repeated over and over again in a multiplication problem. And if I count it up, it's being repeated 1, 2, 3, 4, 5, 6 times, which gives me that exact answer that I have right there. So our power to a power rule says when you have a power inside parentheses and you're raising it to another power on the outside of the parentheses, that you will just simply multiply those two exponents together. So again here, let's look at some examples. If I have x to the 4th power, and I want to raise all of that to the 5th power, power to a power rule tells me that I would simply multiply these two exponents together, and I won't change that base. So this would be x to the 20th power. Okay, if I have a to the 7th power, and I want to square that, I would multiply these two exponents together, and that would give me a to the 14th power. Now again, this is a rule that I can apply even when there's more than one base in the problem. So just for example, I could have x to the 2nd power, y to the 3rd power, and then raise all of that to the 5th power. So you would do here just what we did with that product rule. You're going to have to use your power to a power rule for x and then for y. So for x, we would multiply 2 times 5, which would make this x to the 10th. And for y, we would multiply 3 times 5, which will make it y to the 15th. So notice, if they introduce more variables, I just use the power to a power rule for each variable. If I were to do something like a to the 2nd, b, c to the 4th, and I want to raise all of that to the 3rd power, then I'm going to use my power to a power rule for a, for b, and then for c. So I'll multiply the exponents for a, for b, and for c. So here we go. So for a, we would do 2 times 3. So that would make that a to the 6th. Now think about b here. What are we going to do for b? Well, we would do 1 times 3, which would be 3. And then for c, we would do 4 times 3. So my answer would be a to the 6th, b to the 3rd, c to the 12th. So don't be concerned if they start to throw multiple variables into the problem. You just need to make sure that every single one of those gets that power to a power rule applied. Now, we should also talk about coefficients here. So let's say we have 4x to the 3rd and we want to take all of that and raise it to the second power. Again, this 4 is not an exponent. He is a coefficient. So I have to treat him differently than I would treat exponents. That power to a power rule doesn't apply to him. So I want you to think about what this is saying. We want to take everything that's in these parentheses and we want to raise to the second power. So that's what you need to do to this 4. You need to do what the problem says. This says to do 4 raised to the second power. 4 raised to the second power means to take the 4 and repeat it 2 times in a multiplication problem. So that means 4 times 4. So that would be 16. And then for the exponent part of this, we would use power to a power. So if we're doing x to the third power and we want to square that, we would multiply these two exponents together. So that would be x to the 6th. So keep in mind that these rules that you're learning are rules for exponents. They apply to exponents. For the coefficients, we need to do what the problem says. All right, so let's do one last problem here. Let's do -5, b to the 6th, c to the 4th, cubed. So I want to take everything that's inside the parentheses and cube it. So the first thing I'm going to deal with is my coefficient. What does this problem want me to do with that coefficient of -5? Well, it wants me to raise -5 to the third power. That means to repeat -5 3 times in a multiplication problem. So that means -5 times -5 times -5. If you multiply that out, you will get a -125. So with the coefficient, we do what the problem says. Now we need to use our power to the power rule, power to a power rule. So what we're going to do now is we're going to multiply exponents, and we're going to have to do that for A, and then for B, and then for C. So for A, our exponent is currently a 1. We're going to do 1 times 3. So that'll be a to the third. For B, we're going to do 6 times 3. So that'll be b to the 18th. And then for C, we're going to do 4 times 3. So that'll be c to the 12th. So in power to a power, and remember that means the problem's going to look exactly like it sounds like. You're going to have a power inside parentheses being raised to another power on the outside. What it tells you to do is to raise the coefficient to that power. And then for each base in the problem, multiply exponents. And just so I'm sure that you understand what that means, notice I didn't multiply 1 times 6 times 4. I didn't multiply these exponents together. I multiplied the exponent that was on each of my bases by this outside exponent. So you're multiplying the exponent that is on each base by that outside exponent. So just to kind of recap, exponents are repeated multiplications. The exponent tells you how many times the base is to be repeated in the multiplication. And then you've got these two rules. If we're doing x to the a power times x to the b power, if we're doing a multiplication problem, we keep the base and add the exponents. So that would be x to the a plus b power. And if we are doing a power, like x to the a, being raised to another power, we multiply the exponents. So that would be x to the a times b power. If you have any questions at all about this lesson, then feel free to email and let me know. If you don't get a chance to email, then when you all are back in class next Monday, we can definitely take care of your questions on this. On the assignment you're going to do on this today, I don't think there is really a need to show any work, so don't worry about sending pictures of your work. You can just submit answers on this one.